Hello and welcome to Momento Malum today. In this episode we'll be covering chickpea disease resistance. The chickpea is a self-pollinating diploid legume species and the third most important crop worldwide within that family. The primary producers of chickpea are India, Turkey, Canada, Pakistan, Australia, and Mexico. Although there's a large number of high-yielding cultivars of chickpea available, the production of chickpea is limited by the disease Ascochyta blight. This fungal disease is one of the most destructive diseases in chickpea due to its ability to defoliate the entire plant at all growth stages. This disease can cause a yield loss of up to 1%. As a consequence, various international groups have been trying to incorporate resistance to Ascochyta blight by incorporating wild species into the breeding programs. It is, however, speculated that most of the novel resistant sources are not able to be regularly incorporated into the breeding program because of reproductive barriers. This would be the result of greater genetic differentiation between the different species. There are, however, still instances of crossbreeding between different species of chickpea. Novel sources of resistance are also sought from within the cultivated species itself. This allows for the immediate improvement of current chickpea cultivars in terms of Ascochyta blight resistance. Various sources of resistance were identified within the cultivated gene pool and have been used in several genetic and breeding studies. This is quite useful since when you crossbreed wild and domesticated plants, you get the traits you want, but you also get wild traits you do not want, many of which limit yield. Based on the current information we have regarding the genetics of Ascochyta blight resistance in chickpea, it is very likely that this trait is quantitative in nature. As of right now, 2 to 3 potential QTLs for Ascochyta blight resistance were discovered in hybrids between the common chickpea and the resistant species Cicer echinospernum. This complex trait seems to code for resistance to Ascochyta blight during the seedling stage. Dr. Flandes Galvez would ultimately take on the task of crossbreeding selected resistant cultivars with the susceptible cultivar Laceter to see how the resistance traits are inherited, and in which regions in the gene pool could be used as sources of resistance traits in cultivated chickpea. Dr. Flandes Galvez also analyzed the resistances discovered in various other papers, specifically the resistance found between hybrids between species. And here's a result of those researchers' efforts. Hello, I just want to let you know, if you want to fund this channel, you can do so on the platforms seen in the description below. Through genetic analysis, 6 potential QTLs for Ascochyta blight resistance were mapped out on the chickpea genome. However, only 2 QTLs could be confirmed to be sources of resistance for each disease scoring system and blight condition. The genetic marker LG3 can be considered the major QTL for Ascochyta blight resistance across all growing systems and growth stages. The QTL LG1 seems to only work in a field setting, and the QTL LG2 seems to only work in a greenhouse or grow room environment. Within the framework of hybrids between the common chickpea and the species Cicer reticulatum, at least 1 QTL has been found for resistance to Ascochyta blight resistance. The QTL UBC858 was found to be in the derivation of such hybrids. In both the hybrids between species and the hybrids between cultivated populations, genetic resistance seems to exist on a continuum. The resistance also appears to be additive in nature, with each gene adding a small amount of resistance to Ascochyta blight. And that about covers everything. Thank you for watching.